Hey everybody, meteorologist Liz McGiffin here. And of course, with everyone at home and schools being canceled, I wanted to take a minute to show you one of my favorite experiments to do when I go to school visits. Now, this is one that talks about not only the density of air, but kind of gives you a heads up on how thunderstorms are formed as well. I'll start off by showing you a few things that I have. Big thing right in front of me, this is a clear pan. Honestly, as long as you have a clear tub of some sort, for me, I picked just a casserole dish that I had laying around. You want to fill it, I don't know how well you can see this yet, just fill it about 2/3 of the way up with water. And it's important to make sure that the water's room temperature for what we're doing. Next thing that you're going to need, so where you need the assistance, probably mom and dad or the adult, is food coloring is involved. The reason we're going to need this is to show the difference between cold and hot water. I went ahead and last night took an ice cube tray and made a few blue ice cubes. So you can either dye the ice cubes blue in advance or just use a normally colored ice cube and add a few blue drops to indicate cold water. So we're going to start with that. One thing that we're going to do is talk about the difference in the warm water and cold water. So the reason I like to do this as a weather experiment is because the atmosphere acts like a fluid, so it basically acts like it's water anyway. So I want to show you what happens with the cold versus the hot in the atmosphere. We'll start with just adding the blue though first. We're just adding this to one side of the pan. And again, if you use just the normal ice cubes, you can add those in here as well. And then just to indicate where we have the colder water, oops, try not to drop the whole thing in there like I did. Just add a few little drops of the blue. This is again, maybe just put it on top of the ice cube to show what the cold air does. Another thing that I did in advance was I warmed up some water. Honestly, the big thing is just making sure that you have water that maybe is to the point where it's not going to burn your hands, but to the point where it's at least going to be hot. So you can warm it up in advance. I just popped this in the microwave for about a minute, minute and a half. And again, we're making it red, just to kind of show what happens with warm. Using the traditional color of red for warm and the blue for the colder. You could probably even start by pouring in the water and then adding food dye later, but start with just kind of adding that on another side. So it's important to watch this and just kind of see what happens with the blue and the red. One thing that you might be able to notice right off the bat is the speed. Alongside that, notice what's going on top of the other. Okay, it's already starting to mix a little bit and become purple. But hopefully one thing that you're noticing is that the blue is kind of cutting underneath the red. So we have this red indicating the warm air going on top, blue going right underneath. And this is very much what happens when we have a front that moves across the area. I want to let you know too that as a cold front moves through, generally that's associated with rain and with thunderstorms. And the reason for that, let's see if you can see this kind of well. I don't know how well you can see this, but we have the blue on the bottom and the red on top. The reason for this is because colder air is more dense. You have the molecules more packed together, creating a sinking motion, and more so than that, it's creating a rising motion for the warmer air. The rising motion, that's what creates instability in our atmosphere. And when we have an unstable atmosphere, so the rising of those air particles, that's what's going to create a thunderstorm. Another reason that this is important, purely to indicate that warm air rises, cold air starts to sink, is especially during the winter time and even for the next couple of months as we continue to move out of the cold season, is that underneath a bridge or an overpass, sometimes the cold air can get stuck underneath, creating a much faster cool down. And that's also why the bridges and overpasses can cool down a little faster. So again, once you notice or let this sit here a little longer, you'll notice the color all just kind of swirls together like it has already to create kind of a nice purple. And that for us also indicates when the atmosphere has stabilized. We no longer have those warm air parcels rising up above the cold air to create a destabilization. And this is a fun experiment that you can continue to do with your kids. Maybe experiment a little bit with adding the blue ice cubes versus adding ice cubes and then adding the food coloring, or being a little bit more careful adding the red so it doesn't completely mix in. For now, meteorologist Liz McGiffin, NBC4, make sure to comment with how this experiment works out for you.